Okay, now let's take a look at the implementation. They say step number 1, import the training and scoring data set, and then load our library, and then create the logistical regressions. And they said do not include patron ID as an independent variable is obvious, right? And then coerce a dependent variable to be treated as a factor, right? Yeah, dependent variable treated as a factor, right? So this is important. So we're going to treat this dependent variable as a factor, and then use a subset command. If any, from the scoring data set, right? This is important, right? Where one or more attributes exceed the range of established in the training data set. For example, range for the different users in the training data set is 12 to 12, right? 2 to 12. If any observation in the scoring data set have different values below 2 or above 2, remove them, right? So remove them from where? Remove them from the scoring data set, right? Okay. And then using the predict functions, right? And then combine the prediction with the scoring data into new data frame. View the data frame and answer the following. Okay, so basically, these are the requirements even before you start this. Even before you start this problem, there are 9 exercise problems, as you can see. Okay, so now let's take a look at this actual implementations, right? Okay. Okay, so this is actual implementation. Make sure that you clear all the global environment, right? So just click this button here, right? And then I say yes. And then I assume that you already updated all the packages, right? Just go to the packages and click this update buttons, right? I assume that you already did. And then let's just start. So first, you're gonna read this. I'm gonna just use this options, right? So when you click this, let's just run this, right? It'll show you the. So I need to choose, right? This is what? This is chapter 9 training, right? Chapter 9 exercise training. Good. Okay. And then let's just take a look at the view. Okay, so this is the view, right? You know that it's patron ID and the renewed subscription, yes or no, and etc. Right? Okay, so I'll just. And then what else? Yeah, and then this n row, you can, if you know that this chapter 9 train E, and by the way, for the variable name, I just put the E here to differentiate the variable that I used in my previous lecture, which is chapter 9 training, right? So I put the E, meaning that exercise, right? So, but anyway, this small thing. And n row, I just want to, since the chapter 9 trainee is a data frame, right? I just apply n row, right, to see how many rows, right? So when I run this, hold on, n row run, then it's, yeah, I have a 377 rows, right? And the same thing for the scores, right? So I just run, and then I need to choose what? Chapter 9 exercising, where is the chapter? Okay, chapter 9 exercise. Okay, do not choose chapter 9 scoring, right? You have to choose exercise, right? Chapter 9 exercise scoring. And then let's just take a look at this. You notice everything's the same except this one does not have the renewed subscription, right? Dependent variable. It's obviously, this is for what? This is for the scoring, right? Good. And then what? Let's look at the number of rows. It has 148 rows, right? Good. And then you're gonna upload. You're going to load this library MASS to use a GLM. GLM is for the what? GLM is for the logistical regression model, right? And then they said to make it as a factor, right? Remember they said coerce the dependent variable to be treated as a factor, right? So I follow the instructions, and this is what? This is a factor, right? And then I include everything, right? Except the patron ID, right? Okay, and then data is chapter 9 train, right? It's not the scoring, right? And the family is a binary, right? The family is binary, right? So let's just run this model. Oops, I forgot to load the mess. I forgot to execute this, so I have to run this. And then run the next one, GLM. Okay, good. And then let's look at, so now if you want to answer these questions, and please, you're going to run this summary, right? Summary will tell you a lot of things, right? Okay. Now, now what? Yeah, so they said another thing is remove what? Remove what? By the way, when you run this, right, the idea is the same thing, right? You look at the p-value for each variable, right? And then if the p-value is less than 0.05, right? For example, when you run this, output, and then when you see the p-value for the different users, right? You know that this is, if it's less than is 0.05, then it's statistically significant, right? That means it's definitely affect this renewed subscription. So that means it's important to include this variable in the model, right? If it's statistically significant. And then you also look at the coefficient of this variable, for example, right? And then if it's a negative, then what? Every unit change of the different users, right? It's very likely that it's what? Is going to negatively affect this renewed subscription, right? It's going to be lowered the probability, right? And if it is positive, right? Any variable actually. If the coefficient is a positive, that means what? They will be what? Positively affect the dependent variable, right? The coefficient. If the coefficient is a positive, right? So the concept is very similar to the linear regression model, right? When it comes to interpretation, like p-value and it's the coefficients and etc. Okay, but anyway, so the next is they said what? Remove anything from this scoring data set if the different users is below 2 and above 12. So that means just get the get the data set, right? As long as there are different users, right? If that number is anywhere between 12 and 2 to 12, right? So basically, I use the subset. Where is it? Yeah, I use a subset functions. We use subset function many times already, right? So the subset is going to apply the chapter 9 score, right? It's not a train, right? Here the score, right? Apply this chapter 9 scores, right? Subset is applied to this data set. And then this is AND, right? AND operator. So as long as the different user set is greater than 2, and then it's less than or equal to 12, then yes, I'm gonna just only get those data set, right? So this is a requirement, right? So I call it as chapter 9 score E new, right? So I'll just use this variable new, right? So this new data, it's going to be this new data, right? So I'll just use a different variable, right? New, instead of chapter 9 score E, right? Okay, so just run this, right? And then you can look at the view, and then you can look at how many of them, right? By applying n row, right? And then you're gonna use the predict functions apply to the chapter 9. So this is using the chapter 9 model E, right? Let me just, okay, so what I'm trying to say here is I got this model, right? Chapter 9 model, and then apply this predictive functions using this chapter 9 model, right? And the data that I'm going to use is from this data, right? And the type is a response, right? And then so you get the renew predict. Okay, so once you predict, once you apply this predict function, right? And now, so let's just apply this run. And then now, if you look at the renew predict, right? You see that the output is a probability, right? Like, the first one is probability is really small. It's close to 0, right? And somewhere, if 116th row, the probability is still small. Just so this is a probability, right? This number is probable. It is a what? It is a it's a vector, right? As you can see. So if you just make sure renew predict. It's definitely I mean, you can see that this is an array, right? It's a vector of the numerics. Let's run it. Yeah, it's a vector, right? It's vector of the numerics. Good. And then what you did is, I mean, if you look at this data set, they said what? Combine the prediction with the scoring data into a new data frame, right? So I'm going to use the data frame functions, right? To combine this new predict, right? This one, combine with this what? Chapter 9 score new, right? So this one, right? I'm going to combine using data frame. So the data frame will be accept either what? Either data frame or the vector, right? And then they'll do a column. The operation is it will apply the column-wise operations. So they're gonna combine these two, right? And then you can take a look at this output. Oops. Okay. So let's just combine these two and let's look at the output. You see that now. You can see the new predict. So this is like probability, right? Probability, and then this is what? So this is a probability, and then this is the data set, right? We know that using the data frame functions, we just combine these two, right? And so this is the result. So for example, let's see. Yeah, I mean this one is very close to what, e to the -1. So I mean e to the 1, right? E to the 1. And so this is like this is the probability. So this value should be anywhere, any number between 0 and 1, right? So since this is probability, but it's hard to read. So we need to do a little bit, we're gonna just make this data is more readable, right? So next step is, where is okay. So next step is renewed output, right? I'm going to apply this if else functions, just like I already explained this in my previous lecture, right? It's if this is greater than 0.5, it's yes and no, and then I'll round the probability, right, up to a decimal number, right? 3, right? 3 decimal numbers, right? Numbers after the decimal point. So there are 3 numbers, right, after decimal, right? And then multiply by 100 so that I can so this is going to be like percent, right? And then this is what? Chapter score e new. So these 3 columns will be combined, right? So this column, and this column will be combined using this data frame. And now let's take a look at the outputs, right? Where is it? So let's just combine, and now let's look at the output. You see that now let's say no, and then this is like percentage. Now it's much easier to read, right? So this means what? 99%, right? And this is what? 0.506. About it's very low. It's close to 0. And this is what? 64%. And this means like 0.011%. This is like close to 0 actually. Okay. But anyway, so this is now is much more readable. But the problem is I don't really like this column name, right? I don't really like this column name. So what I'm going to do is where is my implementation? Okay, I'm gonna change the column name. So renewed output is a data frame name, right? And then the first column, I'm going to rename. I'm going to name it as renew. And then same thing for the second column. I'm going to name it as what? Probability. And then now let's take a look at our new data frame after this change is made. Okay, you know that now it's renewed and probability, right? It's much more readable, right? Compared to the previous one, right? Okay, so now I just changed the column name. Now it's much simpler, right? Okay, now I'll just go back to my implementations. And what else? Yeah, I mean, if you want to find how many people say yes from your renewed output, right? From here, if you count a number of yes, right? Or sometimes you need to count number of y's, then this is something you can use. Of course, you can use a subset, right? Functions. And then this is what? This is name of the data frame. And this is a condition, right? Renews is equal to yes. And then you're going to count. So how many rows, right? So, and then this is something like n row. If you want to find the any, if you want to count number of patrons, whose probability is greater than 95%, right? I mean, the patrons, like if you want to find the number of patrons who will say, yes, right? To the who is going to renew their prescription, right? With a probability greater than 95%. If you want to count that number, this is the expression, right? And then, by the way, sometimes you need to, maybe you don't really need this to solve the problems, but another thing that I want to know is, another useful function that you need to know is order, right? If you want to order, right, this probability, right, from, let's say, increasing order, right? So as my option is decreasing option is the false, that means it's what? It's ascending order, right? So when you click this, it shows that, yes, it shows that it's like, this is, so this is the this is like ascending order, right? So but this really does not shows anything, it's very hard to interpret this result, right? It's not really meaningful. So you want to see the whole data frame, right? Instead of this, right? So what you can do it is, the sorted output, right? And then renewed output is a data frame, right? And then this order, right? Order and then probability is decreasing, and this is the row, right? And then for the columns, that means you like to see all the columns, right? Okay, so hold on. Okay, hold on. Okay, so let me see. Okay, if you want, hold on. Let's see. Where's pencil? Okay, so the thing is, when you apply the order to the specific column, in this case the probability, because I want to order, order this data, right, based on the probability, right? And the decreasing is false. That means ascending order, right? From the lowest to highest, when I make it as a false. And you look at the probability, right, of this data frame, the renewed output, and then they're going to order them, right? And then at the end, as you can see, it returns the row number. So the 2, this row number 2, row number 6, row number 9, right, in ascending order. So I guess row number 2 has the lowest probability. Is it really true? Let's take a look at it. 269, right? 269. Remember this number, 269. So go to this renewed output. I use a different color. I'm going to use blue, right? So row number 2, the probability is a 0. And 269, right? The 6 the probability is 0, and the 9, yes, the probability is 0, right? So you can see that it returns the row numbers, right, in ascending order, starting from the lowest and it's probably to the highest, right? Let's go back, and then okay, so then, but as you can see, this is not really useful result, right? So you want to see the whole data frame. This is something you want, right? But that's why I just apply this things. Since this is what, this is a row number, right? So this is a data frame, and this is a row, right? So this is the row, and then here is the comma, and then the column, right? Oops, COL. For the column, I leave it as a blank. That means every column, right? All the columns actually. So when I run this, the sorted output will be, I think it's much more meaningful. And by the way, you probably don't need to apply order function to solve all the problem, but I think sometimes it's useful. So maybe this will help you to solve a couple of problems in the exercise problem, right? So, but anyway, let me just keep going. I'm going to delete this, and then let's just run and see the result. Yeah. So you see that I can see, okay, hold on, let me use the pencil, blue. Okay, you know that it's 0, right? 0, 0, 0. And then, oh, there's so many zeros. And then you see that at the end, the number is increasing, right? Because this is like ascending order. So you know that it's number, right? 0.01, 0.02, and 0.001%, 0.002%. So you know that its number is increasing, right? This is like ascending order, as you can see. Now it's much more meaningful, right? But anyway, so that's like your useful function to know, right? Okay, so now what else? Now you can do the same thing, like, so this is like, if you find out, right, maybe just run this. 71, there are 71 of them. So there are 71 of them, 71 patrons, right? That they're gonna what? They're gonna who said they're gonna subscribe, right? I mean, they're gonna renew their subscriptions with a probability less than 5%. So that means, they're not gonna, if the probability is this low, less than 5%, but then they're not gonna what? The 71, at least it's very likely that they're gonna say no, right? They're not gonna renew their subscription, right? Because the probability is just too low. And by applying n row, you can count those, you can count the number of patrons, right? Okay, so I just show a couple of expressions and the functions, useful functions, for you should know and for you to use to solve the problems, right? There are 9 problems, and also I think it's not only these are the functions that you should know, not only for solving your homework problems, but I think these are the functions that you will probably use for the final exam. Okay, so thank you. Bye.